one of the leaders of Fotech Solutions, Stuart Large, who has a long and detailed experience in the space, particularly also in the oil and gas industry, and is very knowledgeable. Stuart, we look forward to hearing your remarks.
Okay, well, thank you very much. And thank you to everyone in the audience for joining me this afternoon, or perhaps this evening, depending upon where you are in the world. So indeed, I am from Fotech. I'm Sales and Product Line Director, and I'm going to talk to you about the use of distributed acoustic sensing technology to protect vital pipeline assets. And I intend to show you some of the areas of concern or incidents that can occur around a pipeline. I use some examples to show you then where this technology can really help give you peace of mind and protect the interests of your company. So Fotech is, sorry, my slide's not progressing, just one moment. Here we go. Okay, so Fotech is a UK-based company, but we work on a truly international basis. Obviously, the main part of this talk is on pipeline protection, and particularly third-party intrusion and leak detection. We will touch a little bit on security of assets, which is somewhat related, and that could relate to the perimeter around important pipeline installations. Our company also plays in the rail industry. We have a worldwide partner in that sector, and in oil and gas downhole, and there's a number of other applications for this technology, which is perhaps for another day to discuss. The live pipe technology, this is something that is very much deployed in the industry today. We are protecting already thousands of kilometers of pipeline, and we are monitoring for TPI, third-party interference, efforts for theft and trying to hot tap pipelines. We can monitor the progress of PIGs, pipeline inspection gadgets, through a pipeline, and we can monitor for leaks, detect those leaks and raise alarms, alerts should they occur. And this live pipe technology is built around the Helios, which is our brand name for the DAS, distributed acoustic sensor. So let's get the little bit of physics out of the way first, and to explain to you in the simplest terms how this works. So the Helios sensor, which is the black box you see there on the screen, will be connected to optical fibre, and that fibre is typically a industry standard, just the same kind of fibre as was used in telecommunications to bring your broadband to your office and home. But what we do is we fire a laser pulse down that fibre, and in actual fact we do that thousands of times every second. So these little pulses of light are sent down that fibre, and then what we're interested in is the light that is reflected back towards our interrogator unit. Now, if there is some kind of disturbance to the fibre, which comes from acoustic energy, sounds impacting that fibre, or vibrations, then it causes very small strains in that fibre, and that affects the light pattern that is reflected back to us. It's actually by the process of Rayleigh backscatter, but let's not go into too much detail on that, but rather think about this fibre as turned into a string of thousands of microphones or vibrational sensors. And then think about now this fibre cable being buried in the ground alongside your pipeline or around your perimeter or alongside a railway line, and think about the applications for detection of the vibrations or sounds of activities around a pipeline, activities around a fence, or movement of trains or vehicles along a railway line or a road. And that's what we are detecting with that fibre. And we can reach long distances, potentially monitoring up to 50 kilometers of fibre in each direction. So the aim of LivePipe is to provide clear, continuous and confident information. That means that we want to be monitoring that asset, your pipeline in this instance, 24 hours a day, 7 days a week with utmost reliability, and then to provide you with information or knowledge about any threats or concerns to that pipeline so that something can be done about it in a timely manner. So let's start with some examples. This first one is from India, and we've got an installation there. It's a length of pipe probably around 70 or 80 kilometers long, and in the space of just 6 months we detected 26 hot tapping attempts. So the scenario would be that the criminals would be digging in the ground, usually in the night of course, and would be digging down, and probably they've got about a metre or so to dig down to where the pipeline is buried. But what they don't know is that there's a fibre there which is sensing those digging activities. Every time the spade scrapes at the ground, it sends vibrations to the fibre, which we detect. And we allow ourselves a little bit of time to build up some certainty and to know that that digging is, something that is persistent. And then we raise alarms, and security teams are dispatched to location to intercept these thieves. We of course have evidence that is available then for prosecution, and in some instances we've even had the security teams make arrests. Now, it's to be understood that this isn't just a third world problem. Actually, we had a case in the UK here very recently where a team managed to tap a pipeline in the southeast of England, just a few miles from London, and they successfully stole hundreds of thousands of litres of fuel, so end product, which is useful and can be sold straight to market. It was worth millions of pounds. It went undetected for quite a long period of time because there was no adequate sensing solution on that pipeline. The traditional mass balance systems were not accurate enough to detect that loss of product. Whereas we believe that if the DAS technology were deployed, we would have been able to detect the sounds of the digging and the tapping that went on around that pipeline at the point of fitting the tap, and we could have prevented this scenario altogether. As it happens, they did catch the leader of the gang in time. 51-year-old chap was, I believe, has ended up in jail, but he got away with quite a bit of money beforehand. We also had a particularly interesting case going back to India, where actually the criminals didn't just dig a hole directly above the pipeline in the night like the 26 others, but rather they went to a building about 20 meters away from the pipeline, and they dug a tunnel underground, of course, and reached the pipeline. Now, we actually detected the signs of that for some 2 or 3 weeks, and in fact we could see they were working a shift pattern, and the security team were sent to the location and were able to give them a pretty accurate location, but somehow they just didn't manage to find that tunnel. The mass balance system in this case did recognize that when some product was disappearing from the pipeline, but the mass balance system could only give you a region of about 500 meters where there was where this loss was coming from. But that coincided with the DAS data, which reduced the search area to 10 meters. And so we went back to the location, looked more carefully, and actually started excavating around the pipeline, and this is what we found. So the tunnel goes away to the right-hand side in both these images, and that tap has been applied to the pipeline, and so they had started taking product, What we now know, of course, is what the sound of tunneling is, and we can raise alarm to that in the future. Well, of course, we did alarm at the time, but now we've got that greater certainty. Now, not all threats to a pipeline, of course, are from criminals. Sometimes they are unintentional, accidental in nature. Now, one of the biggest single causes of accidents, according to the US Department of Transport, is actually excavation damage. So this will be perhaps another utility company, someone laying a water pipeline or a power cable, or someone doing works around their the perimeter of their home perhaps, and are unaware of the presence of the oil or gas pipeline. And it's estimated about 12.5% of the pipeline incidents over the course of a couple of decades were of this nature. But actually, if you've got the right monitoring systems in place, this DAS technology, this is a pretty easy one to detect. Because those JCBs make an awful lot of noise, and their work tends to be fairly repetitive. And we had a great example down in South America, where we actually alarmed to two mechanical digging events and two locations simultaneously. And we were able to locate each one with an accuracy of just 10 meters. So a security team was dispatched. These 2 points were sort of 200 or 300 meters apart. And when the team got out there, they found, indeed, there's one digger at the first location, digging near the pipeline, and there is the second one, actually digging immediately by the pipeline. And as it happens, no harm was done in this particular instance. It was unscheduled maintenance work that hadn't been notified to the pipeline operator, rather strangely. But the point of this, why I'm showing it to you, is that it's verification that indeed this technology works. Had it been the water company merrily digging away, then we could have got there and prevented them hitting the pipeline. Then we have the issue of leaks. And of course, this is something that gets the industry into a great deal of trouble. There's been multiple leaks reported, in the US, of course, but globally as well. And quite often, these leaks can go undetected for rather long periods of time. This particular case was fairly recent, December 2016, and it's estimated that over 500,000 gallons of crude oil leaked into a North Dakota creek, and it's thought that around 20% of the oil will remain in the soil and never be totally cleaned up. And so this company is going to, has had a notice of violation, and there may well be a fine involved. Time will tell. Now, this may have been a reasonably old pipeline, and so perhaps this technology wasn't available to be installed at the time the pipeline was laid. But we would suggest that any new pipeline should certainly have this technology, and indeed there are options to install fibre around old pipelines which are considered to be at risk. So what happened here was that the pipeline, the traditional electronic monitoring systems that were deployed on this pipeline did not detect the leak, and in fact the pipeline was allowed to leak for estimated around 4 days, which gave time for all that product to make its way into the creek. Whereas the DAS technology should have identified this leak within minutes, and indeed would have located it to a precision of 10 meters and allowed the size of the leak to be minimized. And how does that work? Well, the DAS technology detects the vibrations of escaping fluid. It comes out of the hole in the pipe and disturbs the soil around the pipe, and detects the strains in the soil as, of course, it sort of expands and heaves with that oil running into the soil. Now, how do we know this works? Well, we've done an awful lot of testing. We've done independent testing with the Southwest Research Institute, and which involved literally hundreds of different test points with different types of cable, different flow rates, different pressures from a pipeline fixture. And then we've done it for real, out on location around customers' pipelines. Now, of course, it's not acceptable to leak oil for real from a pipeline into the environment. But what we can do is a pretty accurate simulation of that. And so we have a device that we can insert in the ground a meter or so from the fibre, which is alongside a real pipeline, but perhaps on the opposite side of the fibre. And then we can leak water or gas into the ground at different pressures and different flow rates and through different orifice sizes. And then we can verify that we can see those leaks, that we can raise alarms to them. And we can test this in different locations along a pipeline length where there may be different soil conditions or other environmental factors to consider, such as other background noises like a road or a factory or something that we don't want the sounds of that to be confused with what we're trying to detect. And so we tune and teach the system to recognize the difference between the signatures we're looking for, in other words, a leak or perhaps someone digging around the pipeline, as compared to the background noises that occur frequently in that particular area. So in this case, shown here, we tested 45 tests. It was done on a blind basis, so we were monitoring a total of 34 kilometers of pipeline. The customer set up 9 different test locations, and they didn't tell us where they would be simulating a leak and when. But when they did, we had a 100% success rate in detecting those leaks. And most importantly, we had 0 false alarms through that period. Of course, we don't want too many, maybe 1 or 2 false alarms, we can be excused. But if there were multiple alarms such as that, false alarms, then of course the system would lose credibility, and a real incident could be overlooked and dismissed as a false alarm. So what we have then is this live pipe system, which is actually a rack-based system which incorporates the DAS technology, and that is shipped as a full unit that can be deployed rapidly into the instrument room close to a pipeline and connected to the fibers and start monitoring once we've done our tuning. And so we're going to be giving high confidence alarms to events such as malicious attack, such as the attempts to hot tap the pipeline that we've seen, or simple vandalism, accidental third-party intrusions, excavation, whether mechanical with a JCB or manual, somebody with a spade, the sounds associated with hot tapping. We're going to detect leaks, and also we can track the movement of people and vehicles that perhaps shouldn't be there in that particular, close to the pipeline. So as I said, the system includes the Helios DAS. It includes a Panopto alarm server, which I'll explain in a little bit. And then it must include that single mode fibre optic cable, a standard telecommunications fibre. And so a few statistics here. We have continuous detection and location of the events that may be occurring around the pipeline. We can resolve those, in other words, identify different events as close together as sometimes 2 meters apart. And we can give you an accuracy of 20 meters or better. Often it's down to, say, 10 meters. So that means if we detect an incident, maybe someone digging, we can send the security team to exactly the right place immediately. We can monitor up to 50 kilometers of fiber in one direction from a DAS unit. And in fact, we can go two directions. So we can go up the pipeline and down the pipeline, or take in different branches coming from other directions. Now that range, that does depend on the quality of the fibre that we're working with, and on the environmental factors, and exactly what it is the customer thinks their threats are, what they need to detect. So let's talk a little bit about this Panopto server. The DAS sensors, the Helios DAS sensors, they tell you when there are certain events occurring around your pipeline. So if somebody is digging, we'll raise that as an event. And each time the spade strikes the ground, or the digger digs up another section out of the hole, we'll say there's another digging event. But what we need is to apply some intelligent logic to that, and that's what Panopto does. It will factor in, okay, there's somebody digging, how long have they been digging for? Perhaps it goes on for 30 seconds. We say, okay, it's reasonably persistent, we need to pay attention to this, let's raise it as a green alert. And then the digging persists for longer. So maybe it's a minute or two now, and we say, okay, we need to elevate that to amber. Well, then ultimately it may become a green, we'll turn to a red alarm. And at this point, it's because we are really getting worried that the digging has continued for long enough. We're certain that that's what it is, and we need to get somebody out there before they reach our pipeline. And the thresholds that we set for these alarms can be agreed through discussion with the client. If the pipeline is fairly shallow and it's quite a long way from the security team, then we may need to get that alarm out there pretty quickly. But if the pipeline is buried more deeply and we figure it will take them a long time to dig down to it, and it's maybe relatively close to the security hut, then we can give ourselves a little more time to build our confidence level. So on this image here, we've got an example of an event log for a digging alarm. And so you can see we've had to black out the sensitive information about where this installation is. But you can see we've detected some digging. We've given a position on the fibre, and also it will be spatially calibrated. So we'll have geo-coordinates which relate to a position on a Google map, say, so that we can tell the security team exactly where to go. And you can see the times at which the alarm has been escalated through its different levels. And then there is some feedback saying when the security officer reached site. In this particular case, they saw 3 people with torches who ran away when they were disturbed by the team. And when they got there, they found excavated soil and a pit, because they had been digging above the pipeline. So here's an example, and this is probably my favorite one actually, of this process working really well. So this was a live pipe solution that was deployed in South America. And in this instance, we got a rather unexpected signal. It was actually one we hadn't really seen before, but because we were paying attention to the data, we saw the sort of repetitive nature of the signature, and we raised it to the attention of our client. At first, the clients looked at it and he said, well, looking at where that is, it's in the middle of rainforest. Nobody goes there. If they're going to try and thieve from our pipeline, they're not going to go to the trouble of going that far into the rainforest, because they couldn't be able to get the product out. Well, we assessed that data, and we convinced ourselves that there's no way that's created by any sort of natural events. It has to be human activities, because it is repetitive in its nature and consistent. So we insisted that somebody went out there, and this is what they found. They found a seismic exploration crew drilling holes in the ground very close to the pipeline, ready to put explosives in. This would have been a catastrophic accident if these guys had been allowed to carry on. What had happened, unfortunately, was that they put their trust in a GPS system and that was supposed to maintain a minimum safe distance from the pipeline. They knew the pipeline was there, but the GPS, because of the canopy of the trees, had degraded the GPS signal, and a bit like when you're in a city sometimes, around New York say, your phone can't always recognize where you are, and you end up a few meters on the map away from where you should be. And so these chaps were drilling far too close to the pipeline, and as I say, if the explosives had gone in, then there would have been a big bang. So this was a great success for us, because the client, of course, saw a major disaster averted, and they signed off and approved that system very quickly. So a little bit about the practicalities of installing this. So we have three main components to the live pipe solution. We make it modular because we understand that sometimes a client wants to start monitoring a certain section of pipeline, and then maybe in the future additional pipeline is added and they want to expand the system out to include that. So they have three main elements. We have a monitoring and sensing station combined. We have sensing modules, and we have monitoring modules. Now the sensing modules contains the DAS sensors. So that is, they are connected to the fibers alongside the pipeline and doing that sensing. And then the monitoring, is about taking the data from the DAS sensors and turning that into the actionable data. Now a monitoring station, which includes that Panopto Server, can potentially be monitoring several DAS sensors from several sensing stations. And so we can connect these in a string. Now, we also have a new product that is out now. So rather than having a pair of DAS sensors, one monitoring up the pipeline and one down, we have a combined, what we call a dual channel DAS sensor, which can monitor two directions. And what this does is it makes for a more economical solution for the client, because they can now monitor a greater length of pipeline from one DAS sensor, and therefore do it more economically. And then we network all of these sensors together, so we can potentially cover hundreds of kilometers of pipeline, and then bring all the data together in one or two monitoring stations. And these monitoring stations can be synchronized as well, so that should one be affected by power outage, say, then the other one will keep monitoring the whole pipeline, and then they can synchronize with each other afterwards. So we introduce some redundancy for the benefit of the client. Just to explore a couple of other areas here. So I mentioned that we have this two-channel DAS sensor. So this opens up some other possibilities. We monitor and protect perimeters around installations, obvious things like airports, prisons, military installations. But this could also be around key assets along the pipeline. Perhaps the terminal or the pump station or the instrument rooms themselves. And so we can put fibre in the fence around the perimeter, so that if somebody is trying to climb the fence, cut through the fence, or dig underneath the fence, we can detect them and give early warning. And by having two channels, we can monitor two ways around that perimeter, clockwise and anti-clockwise. So if somebody tries to be smart and cut our fibre that they see on the fence, well, we've still got it covered, because we can monitor one half from the left and one half from the right, clockwise and anti-clockwise. We can also monitor both sides of a corridor. So whereas most pipelines might be a single or maybe two pipelines, and we'll have a fibre buried in the ground, and we're able to provide protection for those pipelines, in some parts of the world, you can see several pipelines all laid along in a corridor, and that corridor can be tens of meters wide. In this case, it may actually make more sense to deploy the fibres at the edges of the corridors. so that we can detect people passing into the corridor and see if they pass out the other side. Or this could be a railway line or a road, so that we can again, monitor for people trespassing on that railway line. And of course, with two of these sensors, we can be looking up the asset and down the asset. And then the other thing to consider is integration with other systems. So as you've gathered now, we will detect somebody intruding on our pipeline or digging around, let's say, and we are getting an accuracy of, say, 10 meters. Well, if there are CCTV cameras, then it means that we can automatically integrate with those cameras, and the right camera can be selected and then panned round and zoomed in to that particular point on the ground and can start recording. And it allows the CCTV cameras to be controlled without the security guard having to monitor each one all of the time manually. Or likewise, we can integrate with drones, and perhaps it's still fairly early days for this technology, but there's a number of drone companies that are interested in the pipeline space. Well, somebody needs to direct those drones and tell them where to go and where to focus their cameras. And so that's where DAS technology comes in. Again, we give them a precise location where there are some activities. The drone could potentially automatically fly out there and get eyes on the ground, with, of course, the added safety that, if there are criminals there, that a security team isn't going to be, or sorry, rather, a drone isn't going to be threatened in the way that a security team could be. So really, to summarize, hopefully what I've shown you is that by using this fiber optic technology, we give ourselves a smart way to detect specific activities that may occur around the pipeline. That can be the interference from people, third-party intrusions, either accidental or malicious. It could be leaks. I didn't talk too much about pig tracking, but of course the pig makes a sound as it travels through the pipeline, causes vibrations, and we can detect and monitor its progress through a pipeline. And should it get stuck, then we could tell you where that has become stuck. And in one particular case, we actually saw a pig break into two pieces, and we're able to determine where those two pieces of pig ended up, which could be quite key to a client because they don't want to have to dig up long sections of pipeline. They want to dig up this particular point where they know those pigs are going to be found. But also critically, we can, through our clever software, we can exclude some of the background noises that may occur around the pipeline. We had an example in India where the pipeline ran past an agricultural area, and the farmer had a lot of irrigation pumps set up. And so those pumps will vibrate, and if we didn't tune them out, then they could cause some false alarms against some of the things we're trying to detect. But we, of course, we do know those pumps operate at particular frequencies, and we're able to isolate that signal and get focus back on what it is we're trying to detect. We give clarity. So we're very clear in the nature of the alarm that we're raising. It can be given to the pipeline operator in the form of an email or a text message or just a display on the screen. And we have high confidence in those alerts. And they give you the details about where exactly on the pipeline it is. And by presenting it on a map, we can also look at other features and the nature of the terrain where these incidents are occurring. And we cover long distances. One DAS sensor can potentially monitor up to 100 kilometers of pipeline, 50 kilometers in each direction. And then we can daisy chain several systems together to actually cover hundreds or even thousands of kilometers of pipeline. And it's a good economical solution that covers the pipeline 24 hours a day, 7 days a week throughout the year. So that concludes my presentation. Thank you very much for listening, and I'd now like to invite questions.
Thank you, Stuart. This is Mark, and before we certainly open questions, you can type them in and I can relay them, but let me just kind of kick it off and ask one. Stuart, this is obviously one of a number of fiber optic sensing is one of a number of systems that can be used for detecting leaks on pipelines. Could you kind of do a compare and contrast with some of the other approaches, and what are the sort of pluses and minuses for them?
Yes, certainly, thank you. So, other key technologies will be a mass balance system, which monitors the mass of products that is put into the pipeline and then looks at what comes out the other end. And of course, it stands to reason that if those two numbers aren't equal, then some product has gone missing. The challenge with that is to determine where exactly the loss is coming from, and that could be a range of hundreds of meters. And so if you're trying to quickly find where that, or even trying to search such a long area to find the point of the loss, whether that be a leak or a theft from a tapping attempt, then it could take you a long time. Whereas the DAS technology can narrow that down to just a 10-meter window. And then you have the negative pressure wave technology, which relies on the fact that when there's a leak, you get little pressure waves that travel along the pipeline, and they are detected. But again, they have the challenge that as the pipeline conditions change, the flow rates are turned up or down, or pumps are turned on and off, that they can be sometimes tricked by such changes. And again, trying to narrow down the exact point of a leak can be difficult. So it really comes down to the accuracy of our system, and the points that it gets you down to that sort of 10 meters. However, we don't have to be seen as a competitor to these other technologies. It certainly makes sense, if you can afford it, to run multiple technologies and to integrate them, as we saw in the case of detecting that tunneling event. We're quite happy to work alongside another technology and use the best of both.
Thank you, Stuart. We actually have typed in a couple of questions sort of on the general category of installation. I may want to try and combine a couple together. First does the fiber need to be installed at the time that the pipe is put down, or can it be both? And also, do you need dedicated fiber, or can you use existing fiber to do this?
All right. Yeah, good questions. Thank you. So the fiber it's obviously preferable to install a fiber cable as the new pipeline goes in, and it can often be placed in the existing trench as that goes in. But there are increasingly options to install a fiber close to a current pipeline. A number of micro trenching technologies, or they could be ploughed in. Obviously, the concerns there are that you don't want your plough or whatever method it is to hit the pipeline that's there, so it requires proper surveying. And then also we're seeing, for example, people like SmartPipe have some technology for repairing old and corroded pipelines, by expanding effectively a new pipe inside a section of old, and they can incorporate a fibre in that in that solution. So that's another good option in that case when you're making a repair to get the fibre in there. We don't need a dedicated fibre cable in most cases. In a number of parts of the world, actually fibre cables go in anyway because the pipeline makes a natural sort of right of way. And Nigeria is a good example where actually when they're putting a pipeline in, they put a fibre cable in because it also allows them to bring broadband to villages and towns along the route of the pipeline. And they also understand that it tends to mean the locals appreciating the broadband they're getting are less likely to oppose the pipeline route. So yeah, because it's a standard telecommunications cable, you can sell the data space on the other fibers, and we just need one fiber for sensing and potentially one or two other fibers for networking our systems together if there's more than one along the pipeline route.
Thank you. So another one is how close does the fiber and the assets have to be to each other in order for the asset to be monitored? Okay, so usually it depends on exactly what the requirements are for the client, and we need to consider the environmental conditions, the soil type, and how deeply the pipeline is buried. So if the objective is to monitor for digging and other TPI activities above a buried pipeline, obviously I've got to dig through the soil and walk across the soil above the pipeline. Then what we might prefer is for that fibre cable to be positioned above the pipeline, perhaps a little bit to one side, in case you need to dig down and make repairs to the pipe in future, and perhaps buried something like 0.5 metre deep. But if you are needing to do leak detection, then we should think a little bit more about how the fibre is positioned relative to the pipeline, because then we would really like to be sort of 0.5 metre or 1 metre to one side of the pipeline, so that we stand the best chance of detecting those vibrations when the pipe leaks. So it does mean that in some instances it could be a recommendation to actually put two cables in two different locations, but that's pretty unusual, I would say. Next question may be a follow-up to the previous question. How small a leak do you think you can detect?
So we've done we have done testing on a number of scenarios. I think I would have to get back to you with a specific number on that, because it would depend upon the product type and the a few other points, the soil type and the pressures at which the pipeline is running. But it gets down to some pretty small numbers and pretty the sort of realistic pressures at which these pipelines operate.
So I have another cluster of questions having to do with sort of remote environments, and could you comment about that? You talked about obviously an application or an example in a tropical rainforest. Does this work well in remote areas? Is it necessary for the equipment to be close in?
So one station can cover up to 100 kilometers. It may be, but it does depend upon the environment and the detection types required. So even if we had to reduce that to say 80 kilometers, 40 kilometers each way, then that gives us pretty good spacing between stations. We do have to factor in that the fiber length may not be identical to pipeline length, because sometimes they put extra fibre in and there's a few extra spools along the way. So we do a site survey will tell us all these things. But actually, the sort of environments, rainforest and deserts or remote locations, in some ways they're easier because there are less complications with the commissioning due to the environmental sounds that come from the activities in towns, villages, cities, or from roads, railway lines, etc. It actually makes our engineers' lives a bit easier. Now, we have done installations through some pretty complex environments too. In somewhere like India, of course, densely populated areas, and we have to factor in, people going about their business by day, maybe things being a bit quieter at night, vehicles, roads, sometimes rivers and running water, or agriculture. And so that's where the tuning process comes in. Our engineers will spend a good few days for each system, and will run various tests along the length of the pipeline. They will actually carry out, simulated digging and potentially, simulate the leaks at various key points along the pipeline to make sure we've got our detection parameters just right.
This actually may have been covered already. We talked a little bit about using legacy fiber and or using dedicated fiber just for was previously installed fiber, or adding fiber after the fact. Are there differences in the installation process between the two, and how do you, when you have existing fiber, are there additional expenses or additional considerations that need to be addressed?
When there's pre-existing fiber, I suppose from our point of view, that probably makes our sell a bit easier, because it means that a good part of the cost has already been borne, and hence, for us to come along and connect in our systems is quite simple, and then we just have to go along the pipeline and make some noise and figure out where that fiber is relative to that pipeline, and tune it to work. Obviously, if it's a new installation, then we get the opportunity to perhaps specify where that fiber should be buried relative to the pipeline, rather than just sort of having to live with what we get. So that could make for a better system in the long run. When the new fiber cable goes in, though, something to bear in mind is that we want to make sure that there's good compaction of the soil around that cable. Rather than just sort of throwing the soil back in above the pipeline loosely, we want to compact it because, of course, we're trying to detect acoustics and vibrations. We want good acoustic coupling to that fiber cable, and so if we can compact the soil, we can get that fairly quickly. If it's uncompacted, you may have to wait a while, maybe a few months, so that soil can settle down and compact itself naturally, and then give us a good response.
Good. I think you've covered that. You've talked about some of the different categories of data that can be detected. Do you store all this information? Do you kind of use it as a way to profile new types of events that perhaps you didn't necessarily originally have the signature for? You'd say explosions or sort of unanticipated intrusions? Or do you have to stick with the, go ahead.
No, I like that question, actually. In some ways, I suppose you lead us into, part of our new product, which was in fact launched last week, the LivePipe 2. This incorporates an advanced processor, which does actually allow us to capture an area of data where we detect an event, and it could be a new event. So ordinarily, we don't keep the raw data. We simply, we use our software and our algorithms to detect events and to raise alarms, and we keep the alarms, but we don't keep the data behind them. But with this new processor, when an alarm is raised, we can say, right, I want to record the data maybe 50 meters each side of that point on the fiber. I want to go back in time a little bit, so it's got a rolling memory, a little bit like your, I don't know, well, we have Sky Plus in the UK. I'm not sure what you have in the US, but it means you can go back 5 minutes and record the data all the way leading up to the alarm, during the alarm activities, and then for some time afterwards. And then you've got that data. We can play it as an audio file so that you can listen to it. Sometimes a human ear gives the best interpretation. And in fact, you can also click on a point on the fiber and listen to it in real time. It could be while the very moment where you think digging's occurring, put your headphones on, listen to that point on the fiber and see if you recognize the sounds that are going on. And then, as you say, we keep that data, the area of interest, for potentially, say, 3 months, so that we can pull it up later and refer to it. And so, we've got one client who has us monitoring for TPI, threats to their pipeline, but they're interested to see if we could detect landslides. And so we don't know today necessarily what a landslide sounds like in that terrain. But what we could do is use this system to capture the sounds of those landslides, and then maybe when we've got 10 or 12 of them, we can use those to write our algorithms to detect these automatically in the future.
Yeah, Stuart, you're talking about some of the other applications, and I guess one of the, in addition to pipelines, perimeter security on fences. How does weather or sort of other physical changes in the environment, if it's windy, if there's a rainstorm, is the system still just as effective?
Yes. So when a fiber is buried, then of course it's largely unaffected by the weather. I suppose the one thing to consider is perhaps, if there's snow, then maybe the sound of footprints, above the ground may sound a bit different to, when it's just grass. But we can work around that. When you're on a fence, then yes, we do really have to consider that wind. Of course, it could make the mesh of the fence flap and vibrate. So we're quite specific then in the design of that fence. We want it to be properly tensioned, and we want that fiber cable to be installed, clipped on at regular intervals so that it's nicely secured. And we say that signs should be removed from the fence. The shrubs and trees should be kept clear of the fence so that they don't, bang against the fence and perhaps be confused with somebody trying to climb the fence. So yes, we do have to be a little bit specific, but if you follow those recommendations, then you're going to have a good working system with few false alarms. The trick then is, where we do have what we might call as confusers, is we use our software to isolate those events and differentiate the ones that matter.
The next is perhaps a detailed installation question, but would you recommend using loose tube fiber or tight buffer fiber? Does it make a difference? And if so, which do you recommend?
We prefer a tight buffer fiber. Because it comes back to the acoustic coupling, knowing that those vibrations are going to reach from the soil to the cable wall, and then get through the cable wall to the fiber and translate as a disturbance on that single mode fiber. Yeah. So I would say, I would just add, that is it's a good question, and so it is something for people to consider if they're going to put these cables in the ground by their pipeline, because perhaps in some of the early installations where people weren't perhaps thinking about this sensing technology, they would make they would choose what was essentially a communications cable. And then, of course, it's all about protecting it from rodents and probably and going for something that's rugged and perhaps the cheapest sort of cost-effective solution. But when you start thinking about sensing, then you have a few different considerations there, and so cable construction is something the right choices can help with our sensitivity. That's for sure.
Well, I think we're coming up to the end of the hour. This has been a very informative discussion. I know you've got contact information available on the last slide, and I'm sure, Stuart, you're available to answer a more detailed question. Also, obviously, because, well, for all people, but not just on time zones, just a reminder that within organizations, you can always access our FOSA webinars on our website. We have this one will be posted in probably the next 12 to 24 hours and will be available to be downloaded, as is additional information. We will be having future ones, some of webinars that will be coming up, as one with Frauscher that will focus in some more detail in one of the other major applications on long rail lines. But thank you very much for what has been a very informative discussion.
Thank you very much. I've really enjoyed talking to everyone. And thanks for the questions.
That concludes our presentation.